Welcome back. In this lesson, we're going to look at values in scientific notation that have negative powers, meaning they are very small numbers. Again, just like in the last lesson, very similar criteria for success, ensuring that I can accurately write a number in scientific notation, that I can identify which is greater or smaller, and by a magnitude of 10, how many times greater or smaller. So if it's 10 to the second power greater, then I know that is 100 times greater. And finally, that I can fluently move back and forth between standard notation and scientific notation form. Let's practice converting between scientific and standard notation. We'll go to the first one, 2 5/10 times 10 to the negative 2. So again, knowing that my n is negative, that means my number is going to get smaller. So I'm going to put 2 5/10, and I'm going to move my decimals to the left. How many spaces? Just twice. So it's just going to go once, twice, and I fill in that space. So that's my number in standard notation, 0.025. Let's look at the next one. 3 47/100 times 10 to the negative third. Again, my n is negative, so I'm going to move my decimal to the left. Once, twice, 3 times. Fill in the space, and there's my number, 0.00347. That's actually though the last one because it's also written in scientific notation, and again it's negative, so I'm just moving to the left. So 5 4/10, just moving it over one time, and I'm just getting 54 hundredths. So these are not too difficult. Once you know it's negative, you're moving to the left. If it's a positive exponent, you're going to move it to the right and make it bigger. I'll make the last one in another color. 0.035. Again, I know that I need to make this number smaller, so my exponent is going to be negative. I want to put my decimal behind this number 3. So it should be 3.5. How many shifts will that take? 1, just 2 shifts. So 3 5/10 times 10 to the negative 2. Hit pause and jot this down. And you're going to get a lot more practice moving these numbers fluently between scientific and standard notation. Take a moment and read this question. Okay, so Harry's looking at some cells, the diameter of cells, so they're very small for a nimbus and a fireball. And here are the two dimensions. Now, in future lessons, we'll learn how to actually add or subtract them in scientific notation, but in this lesson, we're practicing fluently going back and forth in form. So what I'm going to model for you today is changing these numbers into standard form, subtract, and then I'll go back into scientific notation. So here we have 6 times 10 to the negative 2. So I'm going to write my 6 and put a decimal. Remember, my exponent is negative, so we're going to move to the left 2 times. 1, 2. So I have my first number, 600. Let's do the same thing for a fireball. 4 times 10 to the negative 3. So 4, I add a 0. 1, 2, 3. So I have 4,000. Okay, let's subtract. 600s minus, remember, line them up, 4,000s, and that gives me 56,000 when I subtract. So let's turn this number back into scientific notation. Where do I want that decimal? I want it behind which digit? Behind the 5. This is where I want to put it. So how many shifts do I have to move the decimal? 1, 2. So my answer is 5 6/10 times 10 to the negative 2. All right, So now just taking a look, which one matches our work? It is definitely not the first two, and you can see the common error is that the person just subtracted those two numbers to get 2. That's all they did. Common mistake, makes a lot of sense. Let's look at the other ones, and they're both very close. One is a distractor. The one that matches our work is 5 6/10 times 10 to the negative 2. So the other is our distractor. Hit pause and jot this down into your notes. And get more practice. We're just fluently moving our numbers back and forth in form. And I will see you in the next lesson, Math Marvels. Be well.